Hi class, today we're going to learn about the constant velocity formula. To review, let's go back and look at a position versus time graph for a tumble buggy or a car, whatever we did in our lab recently. We saw that we got a linear line for something that's going at a constant speed, and we got the equation of the line y equals mx plus b that you know from algebra. Now I'm going to go ahead and do some things here. Just go ahead and follow along. So y represents our y-axis, and our y-axis is x, but I'm going to call this x with a little f, meaning like our final position. And then we know m is our slope, and hopefully by now you know the slope is the velocity. And on x, our x-axis, we have time, so I'm going to put t for time. And then on our y-intercept, which is b, that represents our starting point. So it is a distance, but it is a starting distance. So I'm going to put x0, which represents like the starting position at time 0. Okay, so I've rearranged this equation, and what I can do is I can subtract off the initial starting position from the right side, and I get this. And then in physics, what we can do is we can say your final position minus your initial position is going to be something called delta x. Delta is a Greek letter, and it means the change in x. So change in this case, we're dealing with x, our position. So this is just going to represent how far did the person actually travel from your final point to your initial point, and that derives the equation distance equals velocity times time. And you guys know this equation because if I said how far do you go if you're traveling 60 miles an hour for 2 hours, you would go 60 times 2, and you guys all know that you would go 120 miles. We're never really going to deal with head starts. We're not going to ever really need to use this equation right here, this one that has the initial position and the final position. We're just going to have objects traveling certain distances, and that distance is going to be delta x. Just get used to seeing that delta x because it comes up later in chapters. All right, now let's go ahead and use this formula to solve for problems. Here's the formula up here on the top right. You are never going to have to memorize equations in this class. They'll always be given to us. So let's go ahead and define each one of those variables and go over some of the units you'll see. So v stands for velocity or speed, and that will commonly be, that's going to be commonly meters per second, miles per hour, or maybe kilometers per hour. Delta x, like I mentioned, is going to be distance. That's going to be measured in meters, feet, or miles. And t is going to be time, obviously, and that's going to be measured in seconds, hours, sometimes minutes. All right, so these problems are going to be really easy. It's just going to be plug numbers in, go to your calculator, and solve. I'm going to show you how to write out your givens and get an answer with the correct unit. So it says Brennan runs a 50-meter race at 8.3 meters per second. How long did it take him to run that sprint? Okay, so I see a 50-meter race. Meters is a distance, so that's my delta x. The speed, I can tell that's a speed because it's meters per second, distance divided by a time. So that'll be 8.3. And I don't know, that's a question mark, how long did it take? So what I end up doing is I write out the formula, delta x equals v times t. I plug my numbers in underneath, so these are my substitutions. So that's going to be 50 equals 8.3 times time. And at this point, you would go to your calculator, and to get t by itself, you would divide 50 by 8.3. And I get 6.02. I usually go to 2 decimal spots. 6.02. And you have to tell me, what is that? Is that seconds? Is that hours? Is that minutes? And if you look in the unit of the speed, I see that it's seconds. So time equals 6.02 seconds. And we are done. Moving on to the next one. Jessica and Lucy are traveling in a car at 72 miles per hour for 9.5 hours. How far did they travel? All right, so I see miles per hour. That is my speed, so 72. My time is 9.5 hours. And my distance, I do not know. So I have one equation for this chapter, so that's distance equals velocity times time. I don't have to rearrange. I can just multiply the two numbers. 72 times 9.5. 684, and again, I got to look to see what type of distance that is. 684, and within the speed unit, it is miles. I'll do one last one. A toy car travels 343 centimeters in 9 seconds of time. I don't know the velocity, so I'll go delta x equals v times t. And that'll be 343 equals v times my time of 9 seconds. I would go ahead and divide both sides by 9, and my velocity is 38.11, and I should have a distance over a time for my unit. My distance was centimeters, and my time was seconds. That is it. They should be very easy and quick. Thank you very much.